So, as I told you, we are going to have a first quiz next week, and it's going to be probably a little over an hour with plus 100 and something point. And you are allowed to bring one-page cheating sheet, one side, A4 size, one side, single-sided, and handwritten, preferably. Oh, no magnifier is allowed. So that means it's not allowed, okay? So the previous lecture covers that the complex numbers actually are close to four basic arithmetic operations, right? Addition, subtraction, multiplication, and division. So they can be defined for functions. And actually we covered the simple functions like cosine, sine, cosine hyperbolic, sine hyperbolic, tangent, etc., etc. So we are going to be looking into a little bit more about those functions, especially for polynomials. Sorry. The simplest polynomial is z. Or z square. X square, iy square, ixy minus iy, So x square, we have 2i xy minus y square, x square minus y square, I 2xy. So we can continue like this, like a z to the cube, x plus iy, x plus iy, iy is actually x square minus y square, 2xy, x plus iy. I'm doing this to let you be familiar with the complex numbers, complex variables. So for the real part, we have x cubed minus xy square plus I2 x square y, I x square y minus I y cubed minus 2xy square. Okay, I like to make a copy. No. Copy and delete. Let's see. Paste. Okay. So I don't have to write it again, right? So we can continue. X cubed minus, combining these two, we have 3xy squared. And this 2 I3 x squared plus y and minus iy cubed. So we can rearrange x3 I 3x squared y 3xy squared minus iy cubed. Probably if you remember the binomial expansion, a plus b to the cube is a3 plus 3a squared b 3ab squared plus b to the cube, right? So set a equal to x, b equal to iy, then we have x cubed plus 3x squared iy 3x iy squared iy cubed. We call this cube. This is called square. So square means 제곱, cube means 세제곱. So we have I square is minus 1, I cube is minus I, right? So we have 3x cubed, 3i x squared y, minus 3xy squared, minus iy cubed, right? So we can continue. Probably you like to do like z to the n as a homework. Homework means you just do it at home and you don't have to bother to turn in. You don't have to submit. 내 수업에서 호목이라고 하는 거는 그냥 해보라는 거예요. 낼 필요는 없어요. Actually, I learned this from very hard lesson. But when I first came to join this university, I usually give a homework and then ask you to submit and I grade. But I found that usually when I ask for homework, then about 30% of students will actual homework, and the rest is just copy the other students. So I just realized that it's not worth it to just grade all the homeworks. 옛날의 경험을 보면 학생들이 숙제를 내주면 한 20-30%는 자기가 하고 나머지 학생들은 카피해서 내더라고. 그래서 이것도 채점한다는 게 별로 쓰는 의미가 없어서 after that, I just give you homework, just do it at home. And usually the result of your homework will be represented by the score grade on the score on the quiz. One of the important property of function is whether it is single valued or not. Assuming you have a vending machine, you have a different, you put coin and you select the button, right? Then coffee out. So coin in, or money in, usually. Coffee out, right? So it's like a function. But always you have just one cup of coffee out, right? If the value of the coffee is 501, and even if you put 1,001, you still get just one cup of coffee and the exchange. I mean, there is no 2 cups of coffee out, right? So for every money into the vending machine, you get only a cup of coffee, right? That's a single valued function. So for every value of money you put into the vending machine, you only get a cup of coffee, just one cup of coffee, right? So input and there is only one output. That's a function. There can be several inputs to the function, but you will only get a single value. However, this may not be true in complex variables. For example, exponential I 2 pi cosine 2 pi I sine 2 pi, right? And cosine 2 pi is 1. Sine 2 pi is 0. So this is 1. So normally, z to the e pi should be the same value, right? You just multiply it by 1. So it shouldn't be changed. Gives same value. How about you take a square root? You have a z to the minus. Is it the same value or not? Let's say we define set z to the 1/2 square root of z. Z to the exponential I 2 pi to the 1/2 is z to the 1/2 exponential I pi, right? Square root of z exponential I pi. Uh-oh, we have some trouble. Exponential I pi is cosine pi, right? Plus I sine pi. What is the value of cosine pi? -1, right? Sine pi, 0. So It could be that for complex variables, z and z times exponential I 2 pi can have different values, and you take a square root. So z to the 1/2 have different values. Outcomes. So complex variables, like a fractional power, may not be single valued. So we have a very important lesson that. Am I loud enough? May not be single valued function. But there are cases that we only need to consider single valued. So what do we do? Fractional powers. Single valued. What do we do? So we have to make a branch cut. For example, this is z, this is z to the exponential 2 pi I. So you cannot cross. Crossing is not allowed. Then, if you like cut some x-axis, right? So this is called the branch. This is called branch. And limit your theta to 0 to 2 pi. And this is called branch cut. So if you limit the theta to 0 to 2 pi, then still z to the 1/2 is single valued in this function. Then z to the 1/2 can be a single valued function. So this property will be used quite often in the following classes. So in general, z exponential I 2 pi n is also same, right? N is integer. So, for example, if you take a log theta, pi n, then log z, log r plus I theta plus minus 2 pi n. And for single valued function, we take a big L. Log, we write log c as log r plus I theta, and we limit the theta from 0 to 2 pi. So we take a branch code again, and the x-axis to make a log function single valued. So anybody who hasn't taken calculus or 미적분 in high school, raise your hand. 고등학교 때 미적분 안 배운 사람? 다 배웠어요? Okay, good. And also you take calculus 미적분 in freshman, right? Freshman years. Some other functions such as inverse cosine, say cosine inverse z. We can see that whether this function is single valued or not. So z is cosine w, right? Is exponential iw minus iw, or 2z exponential iw exponential w. So exponential iw square minus 2z exponential iw plus 1 is equal to 0, right? So exponential iw is z plus minus z square minus 1 half so w is minus I log z plus minus well, sometimes you just write down as plus. Etc. etc. So next question is, now we have defined the complex functions exponential, cosine hyperbolic, polynomial, logarithmic function, and inverse function. So the question is whether we can differentiate and integrate. So maybe we can take a break for a few minutes and continue.
지난 첫 수업은
네.
종종 수요일 구별해가지고
네.
그러니까 그 수업하신 거는 유튜브를 통해서 봤는데
네.
그 출석이
출석이요? 아, 그때 수업 신청 안 했었어요?
그때 수업 시간이 안 돼 있어서 출석 체크를
출석은 따로 안 불러요?
감사합니다.
강의는 유튜브 통해 봤어요?
유튜브 봤어요.
네. 지난 시간에 부탁 부른 다음에 새로 등록한 사람 있어요? 한 명 있는데 또 있나? So I forgot to stop the recording, so maybe there is empty recording for about 10 minutes when you replay the YouTube class. So sometimes you can use ln, same as log e. So we can use ln and log interchangeably in my class. So before we proceed, maybe you can just take a brief review of differentiation. So for real variables, a function fx is differentiable if at x0 if number 1 fx is continuous. And number 2, left and right derivative exist, and they have actually it should be plural. continuous. A function fx is said to be continuous if at x0 if there exists epsilon delta such that for every x minus x0 is delta fx minus x0 is epsilon. The definition of the continuous function is the following. A function fx is said to be continuous at x is x naught if there exists epsilon delta greater than 0 such that for every x minus x0 less than delta, fx minus fx naught is less than epsilon. So if you analyze this paragraph in English grammar, there are 5 types of sentence in English, right? 유형식, 이형식, 상형식, 단식. So what kind of type is this statement belong? Type number 1, A is equal to B, right? So this is the same as A is B. I am a boy. So type number 1, right? So the function is objective. This is, whole thing is complementary. 보어. Actually 보어절. For close. So even if the paragraph is very long, this is a very simple type of English sentence. And right-hand derivative is defined as f plus and left-hand derivative f minus prime zero. Delta. And we should have plus minus, right? That's actually the condition for the existence of derivative. So we have 2 conditions. One, a function has to be differentiable and continuous. And secondly, the right and the left side of the derivative should exist. So typical example of a function that is continuous but the derivative doesn't exist is the following. This kind of function, or maybe simple function. Say 1 x y. This is 1 minus. For example, if we define x as minus x plus 1, x minus 1, right? For x greater than 0, then definitely the function is continuous, right? But if you take derivative, it doesn't exist. Because the left and right side derivative is different. So that is fx is continuous, but derivative at x equals to 0 does not exist. So this is very good example of, so this is a function that how about this? Oh, sorry. Oh, something is wrong. I probably need to wake me up. How about this function? Whether we can have this derivative exist or not. Why? It's not continuous, right? So it's not continuous at x equals to 0, right? So if function is not continuous, then you cannot define the derivative. And secondly, even if your function is continuous at some point, if the left and right side derivative is different, then you cannot again define the derivative. So in order to define the derivative, we have two conditions. One is the function should be continuous at a particular point, and the left and right side of the derivative should exist, and they should be the same. So let's do some practice with, I guess you know, so 1 over x. The derivative you know by heart, minus 1 over x squared, because you memorize. But if we define from the definition, you don't have to memorize. For example, one over delta x plus delta minus 1 over x, right? X plus delta, x minus x plus delta, right? Delta, so they cancel each other. And it gives 1 over x squared, right? Few cases. I guess you know this by heart, and probably have done that in high school. But still, it wouldn't hurt to remember how we derive this formula. How about sine x? We know that if we differentiate sine x, we would get cosine x, right? But probably we have memorized. So let's try to derive this x plus delta. Sine x cosine delta plus cosine delta sine delta cosine x, right? So sine x plus delta minus sine x is sine x cosine delta minus 1 plus cosine x sine delta. So delta over sine x plus delta minus sine x is delta over cosine delta minus 1 sine x plus cosine x delta over sine delta. So let's consider the circle, unit circle. With the angle delta. So this is delta, right? So this is actually the what Newton did. (1640). For small delta, sine delta, this is square root 1 plus delta square, right? Sine delta is square root of 1 plus delta square over delta. And cosine delta is square root of 1 plus delta square over 1. So, and delta square is 1 plus 1 half delta square. This is a very useful formula that for small epsilon, 1 plus epsilon 1 half 1 plus epsilon over 2. That's also what Newton derived. You can check. I mean, say, if anybody has a calculator, anybody has a calculator, square root of 1.1. Can you calculate? It's close to 1.05. So anybody can check. Yeah. So if you remember this formula, it's very useful. It's actually 1 point epsilon over 1 over n. You can approximate 1 plus n over epsilon. You can do it by your memory. So probably I can copy this part. Copy. And minus 1, right? Delta over cosine delta minus 1. This here, right? We have this is 0, this goes to 0, right? And this goes to 1. So we have, when you take a derivative, we have a cosine x. Paste. So delta sorry, something is wrong with me tonight today. I probably need a strong caffeine to wake me up. So delta over sine delta is 1 over delta times delta over square root of 1 over delta square, 1 over square root of 1 over delta square, right? So if you set limit goes to delta over sine delta goes to 1, right? This is actually called L'Hopital's rule. How about 1 minus, we have cosine square root of 1 plus delta square minus 1 plus delta square 1 minus delta square is approximately 1 minus 1 plus delta square over 2 is minus square root of 1 plus delta square over delta square over 2, right? So take the limit, delta goes to 0, delta cosine delta minus 1 is minus of delta goes to 0, 2 over 1 plus delta square delta. It has to, so it has to be 0, right? So, therefore, Tx t sine x is cosine x. Probably you didn't learn in high school, right? 고등학교에 배웠어요? 안 배웠어요? 그냥 외웠죠? You just memorized. But actually, Isaac Newton derived the formula for cosine sine using this way. So it would be useful to learn this. So you can define the derivative of cosine the same way. So it's a very simple formula, but so it actually. How about log x? Let me see. Let's do it again. And fx log 2dx or ln fx x plus delta minus log x, right? X plus delta plus delta over x. You can have this way, delta over x, delta over x. This is actually the same expression, right? We take a fraction of half x over delta, and then take the delta over x, and it's actually this one, right? But we can put the delta over x log e And Newton also found out that epsilon so say let's check epsilon is 0.1 then 1.1. Anybody has a calculator? 1.1 to the 10? 2 point. It's 59. How about 1.01 to the 100? Something, 2.7 something, right? Right. So eventually it goes to epsilon. So limit take delta over 2 delta x plus delta minus f of x is 1 over x limit delta goes to 0 e to the 1 plus delta over x over delta. But this goes to epsilon e, so 1 over x. So Newton actually found some limit. This is a very useful limit. So now we have done some simple, brief introduction to the derivative. Now we are ready to do the complex function. Now differentiation of fc. Say fc uxy free xy continuous at c is not, and the derivative is path independent. So path independent is actually has the same meaning as the left and the right side derivative. And continuous has the same meaning. That is continuous. delta 0, z minus c naught is delta, then fc minus fc naught is epsilon. That is continuous. So the definition of the continuous is the same as the real cases, but derivative is because delta z, delta x plus I delta y. So there can be two possible paths. One is you set the delta x first and then let delta y goes to 0, or the other way around. So let's choose the two possible paths. Am I going too fast? 너무 빨라요? 좀 천천히 갈까요? 네. 오케이. 내가 아직 코로나에 안 걸려서 계속 마스크 쓰고 있는데 이게 강의하기는 쉽진 않네. So we have 2 points, say Z, path 1. We set delta x equal to 0 and let delta y goes to 0. So delta over f c plus delta minus f is z, dz, delta x plus I delta y, u x plus delta x, y plus delta y, free x plus delta x, y plus delta y, minus I minus u x y minus I free x y. So it is delta x plus I delta y, u x plus delta x, y plus delta y, minus u x y minus I plus, this is plus, right? Free x plus delta x, y plus delta y minus free x y. So path number 1, delta x is equal to 0 and delta y goes to 0. Then delta z, f plus delta z is same as I delta y u xy plus delta y minus u xy plus I delta y I free x y plus delta y minus free x y. So as delta y goes to 0, it becomes I partial y it becomes minus I partial y partial u plus partial y partial v, right? And the path number 2, okay. Copy and delete. Page the same, right? I should delete this and minus I free x y. So path number 2 is this is 1. So it should be path independent. So as a result, okay. Copy, delete. Probably I have to paste. I free x y. Minus I free x y. Probably the S2 is set delta y goes to 0 and delta x goes to 0. We take the limit of delta x goes to 0. Then delta z x plus delta z minus xz becomes delta x u x plus delta x y minus u x y plus delta x over I free x plus delta x y minus free x y. So it becomes partial x partial u plus I partial x partial v. So this is 1, this is 2. It should be same as, maybe I should make a copy, paste. I should move this. Right? So part partial x u is partial y partial v, partial x partial v minus partial y partial u. That's the condition for the existence of derivative. And it has a name called Cauchy-Riemann condition. So Cauchy-Riemann condition was just simply CR condition. Is the condition that the derivative exists for the function, complex function. Maybe let's take a few minutes break and then continue. Maybe I just. So this probably is the first you need to memorize Cauchy-Riemann condition. For the differential. The step is you check CR condition, then dz, dfz, partial x, partial u plus I, partial y, partial v. So for example, fz, z square, x square minus y square plus I, 2xy, right? So for this function, uxy, x square minus y square, vxy, 2xy, right? So Cauchy-Riemann condition, partial x, partial u, 2x, right? Partial y, partial v is 2x. So they are the same, right? How about partial x, partial v is 2y. Partial y, partial u is minus 2y. So they are the same, right? Therefore, partial x, partial u is partial y, partial v, and partial x, partial v is minus partial y, partial u. So we can see that the Cauchy-Riemann condition is satisfied for this function. Satisfied. Then dc, df, partial x, partial u plus partial x, partial v is 2x plus I 2y, 2x plus IY, 2z. So actually, the formula for the real derivative actually is the same as for the formula for the complex derivative. So possible quiz problem. This is homework. G cube, G4, G5. Find the derivative. So you need to check the Cauchy-Riemann condition first, right? And then take derivative. So I think this is a good homework, and probably I may ask one of the problem for quiz. Real difficult case is trigonometric function. Sin x, cosine hyperbolic y, psi cosine x, sin hyperbolic y, right? Let me double check complex sign. Right. So uxy sin x cosine hyperbolic y, vxy cosine x sin hyperbolic y. So partial x partial u is cosine x cosine hyperbolic y, right? Partial y partial v is cosine x. If you take derivative of sine hyperbolic y, you will get cosine, right? Minus cosine. No plus. Partial y partial. So partial y. How about partial x partial v minus sine x sine hyperbolic y. Partial y partial u is sine x sine hyperbolic y. So partial x partial v is minus partial y partial u. So therefore, CR condition is satisfied. How about then TC TFG is cosine x cosine hyperbolic y plus partial minus sine x sine hyperbolic y. This is cosine g. Therefore, this is number 2. G sine g is cosine g. copy. Okay, I'll just. So sine z, cosine z, cosine x plus I delta y, IY, cosine x, cosine IY, sine x, sine IY, so that is cosine x, cosine hyperbolic y minus sine x, sine hyperbolic y, sine z, sine x plus IY, sine x, cosine IY, cosine x, sine IY is cosine x, cosine hyperbolic y plus I, sine x, sine hyperbolic y. So tangent C is actually cosine x, cosine y, hyperbolic y, I sine x, sine hyperbolic y, over cosine x, cosine hyperbolic y, plus I sine x, sine hyperbolic y. Cotangent to z is 1 over cotangent to z. So most likely quiz problem. Cotangent to z, tangent to z, tangent to hyperbolic z, cotangent hyperbolic z. dz, secant z, cosecant z. Secant hyperbolic z, cosecant hyperbolic z. So you see, secant z is 1 over sine z, cosecant z is 1 over cosine z. So one of the eight that you would probably be asked for your next quiz. And as you can see that this is very complicated, right? You have to differentiate, four differentiations, partial x, u partial v. So I think it will take about half an hour to check the considerable division and final derivative. And if you haven't practiced, I don't think you will get the right point. 연락해 중에 하나 정도 시험에 나올 수 있으니까 호목을 연습해 보세요. 아마 30분 걸릴 거예요. 고시링한 컨디션 체크하고 이런 하는 게 하나예요. 여러분들이 그 미적분 실력을 알고 닦을 굉장히 좋은 처음에 자주 많이 틀려요. 인정할 수 있으니까. So this is going to be your homework this week. I put some special mark here. The dynamic tag y. Even sequence z, it takes about 20 minutes to check the Cauchy-Riemann condition. So, any questions about next quiz? 다 자신 있어요? One final point is complex conjugate. Whether we are interested in this complex conjugate is differentiable. So this is u x v xy is minus y. Partial x partial u is 1. Partial y partial v is minus 1. They are not the same, right? It's not differentiable. Perhaps you can stop here today and see you in 2 weeks. So next week we are going to have a quiz, and there is no class after the quiz. 다음 주는 퀴즈 보고 수업은 없어요.